So just a little bit of a disclaimer. I'm actually not a data scientist, and I was actually just slacking with my team. I was saying, do you guys know how intimidating it is to come to a data science event and talk data science as a non-data scientist to actual data science practitioners? So if I say something wrong, feel free to call me out during the Q&A. And if I can't answer your question, I will provide you with the contact information, my technical co-founder, and he will answer those questions. But I hope this is going to be a little bit of a change of pace for everyone. Instead of diving deep into the weeds of how to deploy data science, I'm actually going to tell you a little bit of a story about our journey as a company of how we ended up using computer vision to identify gun threats to help make institutions a little bit safer. So just a little bit about my personal background. I was born in Taiwan, but I grew up in South Africa. And the reason why that's relevant is because South Africa has one of the highest rates of gun violence in the world. So I grew up in Johannesburg, South Africa. If you ever visit, you'll actually find that it's quite an idyllic city. It's not unlike any other that you will find in Western Europe or North America. But you'll find that things are just a little bit more tense if you stay a little bit longer. People's defenses are high and nobody really walks alone at night. As I mentioned, South Africa has one of the highest rates of gun violence in the entire world. If you ever visit, you'll find that almost every home is protected by electric fences and private security. And growing up, I heard terrifying stories of family friends and acquaintances who were robbed at gunpoint, carjacked, and even fatally shot. And actually, when I was growing up there in the 90s, one of our close family friends, who was also Taiwanese South African, was fatally shot in his own home in a home intrusion. And because of that, my biggest fear as a child was a home intrusion. And because of this fear that I grew up with, I developed a lifelong passion for wanting to do something about the gun violence threat. So because of that incident, my mother decided that we should immigrate to the United States. It was a lifelong dream of hers. So we came to the US, and while the United States is a much safer country, we have a gun violence issue of our own. So over the past 5 years, there are over 150,000 shootings across the United States that have led to over 71,000 deaths. In fact, more people have died over the past 5 years due to domestic gun homicides that have been killed throughout the entirety of the global war on terror from 2001 to present, actually 10 times more, which is absolutely mind-blowing. So as a Marine Corps officer, I was always taught to have bias for action. And that's why last year I decided to put together a team that sought to figure out how can we best use technology to save lives during gun violence incidents. So I solicited feedback from law enforcement leaders across the country, ranging from sergeant all the way up to deputy chief, and really wanted to figure out what were your biggest pain points when it came to gun violence response. And almost unanimously it told me it was a lack of timely and accurate information, because with information, law enforcement teams can immediately deploy to neutralize a threat with pinpoint precision. And with information, building occupants can make the life-saving decisions they need to maximize their chances for survival. But instead, these situations are often marred by chaos and confusion because in that type of crisis situation, nobody knows what's going on. So if you're a school superintendent or a private school principal, a director of security, and you want to protect your institution, what solutions do you have currently available? You may start off with metal detectors. These things typically cost somewhere between $5,000 to $30,000 if you want to be sophisticated. Then you have to pay for staff that are manning the metal detectors. It creates entry bottlenecks for people who are entering into your building. In any case, it doesn't really help you if somebody were to just ignore the metal detectors and pull out a weapon and start shooting. There's a technology called acoustic gunshot detection. Some of them actually incorporate machine learning now, but they analyze the sound of a gunshot and can tell you if there's been a gunshot within a building. But then you're installing these really expensive sensors, microphones, and muzzle flash sensors throughout your building, can quickly become cost prohibitive, and it doesn't really provide any additional intelligence beyond the fact that it tells you, okay, there's a shooter in the building. You may decide to hire armed security, but then you're paying for FTEs that are doing nothing 99% of the time. In any case, if you're a student at a school or if you're an employee at a company, do you really want to walk around people with guns? I was in the Marine Corps for 10 years, and I don't feel like I want to work somewhere where it feels like a fortified military compound. So these are some of the challenges faced by safety and security practitioners. They want to improve their institution's safety and security with technology. They want to mitigate the threat of an active shooter incident, but they're really struggling with issues around cost, risk, and intrusiveness. So, as mentioned, I was soliciting feedback from law enforcement leaders. I came across a training called Run, Hide, Fight. It was a seminar that was actually open to the public. And what Run, Hide, Fight is, it's a training program that teaches teachers how to evacuate their students and resist if necessary during active shooter drills. And after the seminar, I approached Greg, who was a career law enforcement officer teaching the course. And I wanted to get his thoughts on how we can use technology to save lives. And he said something interesting. He said, I wish all of the security cameras at this high school could automatically identify gun threats and provide us with that information. That would be exceptionally helpful. So light bulb went off my head because I do a lot of reading, and I know that computer vision algorithms are becoming increasingly sophisticated, used in a variety of different use cases such as self-driving cars, agriculture, defense, healthcare, but I never came across somebody who had built this product. So at the time I was living in Austin, Texas. I immediately moved back to Chicago to be around my University of Illinois, University of Chicago networks, my two alma maters. I was fortunate enough to, one of the first people I came across was the person who would become my co-founder, Ben Giomek. So Ben spent 4 years at Microsoft leading teams of data scientists and engineers to build out Microsoft's first AI-powered sales product. And he has deep data science expertise, and also he shares my passion for wanting to do something about the gun violence issue. To be honest with you, he should be the one that's giving this talk, so I'm actually hating on him for that, but we're based in New York now. I happen to be in Chicago. But Ben and I decided to jump in with both feet, and we said, hey, if nobody had built this, we're gonna build this. So how many of you seen this TED Talk before? Wow, I'm a little bit surprised. Okay, so this is a TED Talk given by Joseph Redman. He's a researcher at the University of Washington. Him and his team built a computer vision model called Yolo. You only look once, not you only live once. And Yolo is the fastest and most computationally efficient model that's publicly available. In tests, benchmarking against faster RCNN, testing a Pascal VOC data set, it's actually been tested to be multiple times faster without significant sacrifices in mean average precision. So Ben decided, okay, for our initial POC that we're gonna build, we want to center around Yolo. So obviously we need training data, right? Where the heck are we gonna get this training data? Now, the first thought that comes to mind is, why don't you start off with Pascal VOC, COCO, ImageNet, some sort of academic, publicly available data set. Now the problem is that computer vision researchers are typically not collecting photos of guns in their computer vision research. It doesn't really help us. So what we did is we built a script that would scrape Bing Images and Google Images for a bunch of photos of people with guns. So we collected about 5,000 images, guns by itself, people with guns, so on and so forth, annotated the images, and we trained it on an off-the-shelf data set, off-the-shelf Yolo data set. And this is what we got. I hope this works. Is it connected to Wi-Fi? Oh, yes. So this is what we initially start off with. That's yours truly in my apartment. And we start with something, we got, 2 guns. And like a little Tomb Raider there. So yeah, you can see, hey, it kind of works, right? It kind of works. So as you can see, waving a gun in front of a webcam, that's actually not a difficult problem to solve. That's something that even without Ben's help, I could have just read the publications on Yolo and done it myself. Okay, so we can detect this, right? I mean, that's a fairly simple problem to solve, but the issue is, would it actually work in production? Like, if you have a security camera installed right there, this is not what it sees. This is not the type of image that it sees, okay? It probably sees something like this. So we took our janky little POC and we ran it through a repository of over 600 YouTube clips that we downloaded, that we separated from our training data set. And yeah, it basically didn't work at all. Okay, so we're like, okay, well, this is more difficult than we expected. Otherwise, if it's easy, anybody would do it. So this is what we did. So the initial kind of off-the-shelf model that we started off with Yolo, we actually had our data science team build an ensemble model that really customized several layers in the neural net to incorporate some ideas from single shot detector and also faster RCNN, so we can reach a higher level of recall without impacting precision. And also, computer vision, especially when it comes to video, requires an immense amount of compute, right? So we really needed a good way to manage and load balance that immense computational resource requirement. And it just happens that we were able to negotiate $100,000 at AWS credits. So we built our backend architecture on AWS. But most interestingly, we spent a ton of effort actually getting proper training data, really spending effort to curate and also, in some instances, create our own training data. And I'll talk about that in more detail. Again, how do we get this training data, right? If you go on Google Images and Bing Images, I mean, if you guys can actually see this, those are a lot of photos of me in the background. So if you go on Google Images and Bing Images, you download, type in person with gun, download images. The problem is you get action movie shots, stock photos, Instagram type shots where somebody's like showing off themselves shooting at the range. None of these replicate what a real life security camera would see in a crime scene. So we need different training data. So here are the 4 ways. 2 of them are closely related. So obviously, the first thing, top left-hand corner is pretty straightforward. Let's scrape the web, right? But let's go on YouTube and Live Leaks. At the time, we still do have a very diverse team, speak 4 different languages, and we scraped over 1,000 clips of real-life security camera crime scenes in 4 different languages. We built a script that will parse these videos into frames, and we would manually pick out the best frames to train a computer vision model on. And we collected tens of thousands of images to augment our training data set. So based off of that, ran the test again on 600 clips of security camera crime scenes. Again, test data, segregated from training data. And this time, in the first 5 seconds, it was able to identify about 70%, the gun 70% of the time. So good progress. So speaking of web scraping, interesting story. When I was scraping the data, I came across, so a lot of these videos came from this one source called Active Self-Protection. So it's this guy, he's a former pastor, and he retired in Oklahoma, stopped preaching the gospel, and all he does now, he gets crowdsourced security camera footage from his loyal fans, and he talks you through how to defend yourself in each of those situations. He's got like 1.6 million followers. So I said, this guy's got to have more videos than freaking anyone. So I reached out to him. He said, yeah, I'm happy to chat. Pitch him on our idea, listen to his rant about Second Amendment rights. But he bought into the fact that I was a former Marine Corps officer and all that. So he said, yeah, I'll help you. So he gave us a crowdsourced repository of over 1,000 clips that have not been published to the internet that basically nobody else has. So we did the same thing, parsed them into frames with our script, selected the best ones to test, to build our training data set with. And we doubled our training data set just based on the inputs from this one guy. On top of that as well, as we're running some of these tests, we identified certain weapons, certain lighting conditions, distances, and angles where detection just didn't work well. So what do? We created our own footage. So we had an angel investor. He is an avid gun collector. He's over 200 guns in his personal collection. I swear he's not crazy. He just collects a lot of vintage weapons, including like a 1930s era German World War II Luger. And we used a lot of his weapons that he was kind enough to loan to us, as well as the airsoft guns that we bought. And we staged a lot of his footage, and we created additional training data on top of that. So after a few months of doing that, retrained the model a few times, tweaked the model, and we found that running the same test again, we're able to pick the gun up within the first 5 seconds, about 95% of the time, which gave us the confidence to go and actually talk to customers without looking silly. So more and more, we got our first customer deployment in October of last year, a private school in Chicago. I'll tell you a little bit more about it later. And we started getting more customer deployments. But the great thing about these customer deployments, each time they ask us for a walkthrough, because who wants to spend money on something that doesn't work? So we come in with our airsoft guns on Saturday or Sunday when there's no kids around, and we'll walk through and we'll show them, hey, you got an alert. You can see it detected the gun. We collect additional training data that way. And in everyday operations, the false positives that we get, we make sure to retrain a model on that, so we lower the false positive rate as well. So to this date, in October 2019, we have a training data set now of over 300,000 images and we can now identify the gun within the first 5 seconds, well over 99% of the time, and that's based on internal tests and customer walkthroughs. So we made a tremendous amount of progress, and we think that this is probably, at least for this very esoteric problem, we're, I want to say, the best in the world at doing that right now. So no discussion about detection accuracy is complete without addressing the elephant in a room, which is false positives, right? So as you can see, in October 2018, when we had our first customer deployment at a private school, we were getting like 2 false positives a day. The false positive rate was so high that we couldn't actually send it directly to the customer because we didn't want to freak them out. So we would process them ourselves, and we incrementally improve the model. So as we're able to collect more and more training data, as we're able to continue to fine-tune and tweak the model, my data science team has several ways of doing it that, to be honest, I don't even know how to explain to you. But we're able to get now to the point where we get 1 false positive per month on deployment of 50 cameras. This is something that's processed by the customer's internal security team. They'll see the alert, and they'll say, okay, that's not a threat, that's fine. And we'll retrain the model to make it more accurate in the future. But something that where you don't have a computer vision model identifying for threats that's crying wolf every single day. So here is a more up-to-date demo video. We actually have this, we built this in May, so we actually probably have something better now. But as you can see, this is much vastly improved from the initial one I had. So a lot of these are store robberies. We get this question a lot. Why are all these convenience stores? Probably because we don't want to show people actually getting shot. So we thought a convenience store is a real life crime where nobody gets hurt. So it doesn't freak people out. But you'll be able to see that it actually works in a variety of different distances, kind of video quality, and black on black, it's still able to work pretty well. This is the one from a screenshot earlier. He pulls the gun out. It's probably about 10 meters or, yeah, 10 meters or so away. So yeah, that's where we're at right now. Don't have to show the whole thing, but you can probably get the gist of it. So where do we land now after all this work that we did? If you define recall as true positives divided by parentheses true positives plus false negatives, we actually can say that we're 99% plus now based on our internal tests and also customer walkthroughs, just because we're able to pick up the weapon every single time that we tested on. And because of this, we're able to provide this capability. It's actually in production now. We have a real life product that we're partnering with dozens of institutions on that provides you with a capability to react a lot better in a crisis situation, get law enforcement there a lot better, a lot faster, and for the building occupants to better execute their defensive and evacuation measures without being in a situation of chaos and confusion and fog of war. So we've received a lot of positive feedback thus far from the institutions that we work with. Here's an excerpt from an email that Ruth, in a private school we work with in Chicago actually, sent to me a few months ago. And this one's interesting. This one's under NDA, that's why I can't show the photo of the gentleman. But it's with a major property developer that's headquartered in New York City. They're actually in the news recently. But we did a pilot at 3 other buildings at their luxury retail development. And after the pilot, he walks up behind us and he says, you know what? I'm sick and tired of beta testing AI companies that don't work. I swear if my bosses make me look at another facial recognition company, I'm just gonna outright refuse. It's so refreshing to see technology that works. So I'll be really excited to report this. So we're actually in contracting with them now, not just to deploy at their retail development in New York City, but also in some of their low-income housing projects in Chicago and Massachusetts. And the reason why we're able to make him so happy is because we focused all of our data science efforts into solving this one very specific challenge of being the best in the world using computer vision to identify gun threats, instead of a lot of companies who try to do everything at once. And when I was in the Marine Corps, I was taught, if you're strong everywhere, it means you're strong nowhere. So we decided to be strong in one place. So here are some of the other current deployments that we have achieved a ton of progress over the last few months. The result of some of these deployments is that we're able to raise $2.3 million of venture funding from the University of Chicago and several Silicon Valley VCs. And all of these institutions are institutions that already have a security camera system in place that's used forensically and passively, and we turn their security cameras into smart cameras that can actively alert them to threats in real time. So just briefly introducing our team, because they're the ones who do all the data science heavy lifting, not me. I spent too much time playing Diablo 2 and StarCraft. But my personal background, as I alluded to a little bit earlier, is spent 10 years in the US Marine Corps, deployed to Afghanistan in 2012, spent part of my time on active duty as an anti-terrorism force protection officer, which means I trained Marines in ATFP tactics and procedures. Ben, I introduced him a little bit earlier, but his background, more specifically, is that him and his team leverage techniques in natural language processing and computer vision to automatically go and crawl for early stage startup websites that Microsoft can make early investments in. So they actually partner with Microsoft Ventures very closely. Andrew's our salesperson, and the remaining four are data scientists and engineers, all US based with significant experience building deep learning models or building cloud-based applications. So in closing, I'd like to leave you with my favorite quote from an anthropologist, Margaret Mead. She once said that never doubt that a small group of thoughtful, committed citizens can change a world. Indeed, it's the only thing it ever has. Now, I wouldn't dare claim that we're changing the world with what we do, but it's my hope that through our relentless efforts in data science innovation with this very specific, narrow use case, we can help to make our communities just a little bit safer. Thank you. Pardon me?
Do you have a couple questions?
Yeah, sure.
Hello. Hey, Sonny. First of all, thank you, for your service and amazing
Thank you for free business school. It's expensive. You pay taxes, right?
Yeah, that worked better for you, definitely. Why not? So I have a question and a comment. The question is the cost ratio. So you were alluding to the false positive and negatives.
Yep.
So am I right in assuming that false negatives are still more important in the sense you want to penalize them more?
Yeah.
Right?
I would definitely say that false negatives have a bigger impact when it comes to real life deployment, because if somebody brings in a firearm and decides to shoot up the place and it's within a field of view of a camera and we don't catch that, that's obviously catastrophic, not just from a human lives perspective, but also from a kind of PR and economic perspective for the company, right? With that said, we're actually not too concerned about false negatives. And the reason for that is because a computer vision problem when it comes to video is not the same as computer vision problem when it comes to just singular images, because we sample these frames at 3 frames per second that we send up to AWS. That's why we say the first 5 seconds of video. That's 15 opportunities to capture the gun. So the probability of actually missing it altogether within the first 5 seconds of it being in a camera frame is honestly actually pretty negligible. So we devoted most of our data science efforts into lowering a false positive rate, and periodically we'll go back to a customer and ask them to stage another walkthrough just to make sure that we don't have any issues with the false negative rate. Does that answer your question at all or no?
Yeah, it does.
Okay.
Like, it's kind of interesting because I wasn't anticipating that. But yeah, definitely reality must be much different than theory. So yeah, the comment is, so what is your impression about the feasibility on detecting, improvising this system so much in the near future that it actually can detect imminent threat? And what I'm coming from for this comment is that I've seen documentaries where CIA professionals are actually able to predict with a very high probability if a person is carrying a gun, like, concealed weapon.
Okay. Well, from a computer vision perspective, I think that's very, very difficult. Like, for example, I mean, that requires some sort of like behavioral analysis, which not even from a data science perspective, just based on what I've seen in the industry, nobody who claims that feature can do it well. Because I may, put my hand in my pocket and I may pull this out like this, and it could easily look like a gun, but it's really not. So kind of analyzing that behavior is very, very challenging unless you want to get false positives all the time. Based on my research also, we've read articles where there's an Australian tourist in China that apparently didn't pay a fine or something, and they were able to identify him by facial recognition and deduct the fine directly from his WeChat account or something like that, right? And what I was told is that China basically just throws manpower at this problem because labor costs are quite low and the government can afford it. So the false positive issue isn't a big deal for them because they have so many people to be able to filter it out. In a Western country like ours where cost of labor is high, that's something that's typically pretty cost prohibitive. You'll probably just want to have an on-premise security guard if that's the case. So I hope that answered your question, but I'm not sure if it did. There's some other technologies out there that don't have to do with computer vision, but they do incorporate deep learning. There's millimeter microwave sensors that some companies are building. You may have seen the TSA rotating device that you have to pass through. There's some companies, Patriot One, Evolve, I think they're both Canadian companies, that build these wall panels that can scan your body for firearms as you pass through. So that really alleviates some of the problems with like metal detectors, bottlenecks, so on and so forth. But a lot of them are not actually in production yet. They're still beta testing it. So it depends how realistic the weapon looks. Like if somebody brings in a super soaker, that's not going to detect. And we've actually tested that multiple times. But we actually run our tests with airsoft guns. And like I was in the Marine Corps for 10 years, and airsoft gun, unless I pick it up, sometimes you can't even tell the difference. It's just plastic instead of aluminum. So for those realistic type of weapons, that's not a feasible problem for a computer vision to be able to tell the difference. Especially because, I mean, the general rule of thumb I'd say is that if a human being can't tell when looking at a security camera screen, if that's a toy gun or a real gun, a computer vision model won't be able to either because you're having humans manually annotate all these images and training a deep learning algorithm on top of that. So yeah, it depends on how realistic the gun looks. From a practical perspective, if somebody brings a fairly realistic looking toy gun into a school or into a public space, the security team probably wants to know about it. So right now our business model is not sending alerts directly to the SWAT team because even like one false positive per month on deploying 50 cameras, that's too much for that. You would need a way higher accuracy rate for that, basically near zero false positive rate. But for something for an internal security team to see, okay, I don't think that's a threat, especially because I can tell by context. They'll go and check it out. It's not going to be an issue at all. So it still requires human in the loop to decide whether to take further action or not. Most security cameras don't record audio for a simple reason that there could be potentially privacy violations. And I mentioned acoustic-based gunshot detection systems. Those require very specialized microphone sensors and muzzle flash sensors. The reason why they require both is because it's dual factor authentication, so that not any loud bang would trigger the device. So using kind of a microphone built into a security camera, if it does exist, to augment it, probably doesn't add a lot of value. We've looked into some experimental technology. I mean, it's going to be down the road when we're a lot more mature. There's some security technologies out there that can detect magnetic fields. If somebody brings in or has a concealed weapon, they'll be able to generate a higher magnetic field. And to incorporate that into computer vision would probably dramatically reduce false alerts, but that's probably something that's way down the road.
Okay, thank you very much.
Thank you.